Well, folks, we're going to do it. We're going to find the surface integral over S of f dot ds. In other words, we will find the flux of f across S. Our vector field is f of x, y, z is equal to negative xi minus yj plus z cubed k. And S is the part of the cone. Z equals the square root of x squared plus y squared between the planes z equals 1 and z equals 3 with downward orientation. And I think it was awfully nice for the author to tell us to use downward orientation, that we don't have to figure out which orientation to use. So our surface integral over S of f dot ds is going to equal the double integral over d of, now if it were upward orientation, it would be p times the partial of z with respect to x minus q times the partial of z with respect to y plus r dA. That plus would be with a positive k component, and that would be true for upward orientation. Here we're going to use notation p, q, and r. Here we're going to use p, q, r dotted with partial of z with respect to x, partial of z with respect to y, negative 1. That negative 1 is the thing that gives us the downward orientation. Now let's go back. F is equal to negative x, negative y, z cubed. And for the surface, the cone here, z is the square root of x squared plus y squared. So the partial of z with respect to x is going to be x over the square root of x squared plus y squared. The partial of z with respect to y is y over the square root of x squared plus y squared. And then we're going to use that negative 1. Let me resituate this. There. Now I have my room to write dA, and this is the line integral, surface integral over d. Oh, what section are we in? All right. Now we have kind of an issue here, because dA has at most 2 variables. We know we have x's and y's, but here we have a z also. So for z cubed, we're going to go back to the fact that z is the square root of x squared plus y squared. So that will replace z cubed. It'll actually be this x squared plus y squared to the 3/2 power. We'll form the dot product and all, but we still need to figure out dA and like which order, and our region D. So let's visualize what we have. Our surface is part of the cone that opens up, and between the planes z equals 1 and z equals 3. So I'm visualizing a cone that's been sliced a couple of times, and we only care about the part that goes from 1 to 3. For good measure here, here's our downward orientation. Now this gives us a region in the xy plane of 2 concentric circles where the radius goes from 1 to 3. And theta goes from 0 to 2 pi. You probably saw that coming here. We're talking about circles in the xy plane. So we are going to do just a little bit of work here. I'm going to keep it as D here for now, because we still need to form the dot product. Negative x squared minus y squared over the square root of x squared minus y plus y squared, excuse me there, minus x squared plus y squared to the 3/2 power whole thing dA. I think now is a good time to convert it to our polar coordinates. Negative x squared minus y squared is negative r squared, but the denominator is r, and so we end up with negative r for that first term. X squared plus y squared is r squared. Square root that and cube it. Our integrand is negative r minus r cubed. dA is r, dr, d theta. Note this time we did switch from x and y into r and theta, so we need r, dr, d theta. R goes from 1 to 3, theta goes from 0 to 2 pi. I will leave it to you to confirm that the answer is negative 1,712 divided by 15 times pi.